Hey guys, today we're going to talk about enthalpy. By definition, enthalpy is the total amount of heat that is stored in a system. This can be stored in potential energy, it can be stored in kinetic energy, it can be stored in the molecules and the atoms of the chemical bonds. Specifically, we're going to be paying attention to those atoms and molecules in the chemical bonds. Enthalpy can be described as endothermic or exothermic, and these two statements seem pretty easy, but they always get a little confusing. So, endothermic is when heat is absorbed by the system. This means that the system feels cold. Things that are considered endothermic. If you have one of those fancy ice packs where when you buy it from the store it's normal, but there's a little tube on the inside and you break that tube open and shake the ice pack up, that's considered an endothermic system. When your hand or your knee or whatever is hurt touches the ice pack, it's pulling that heat from your hand to make your hand feel cold. On the other side, we have exothermic systems, and this is when heat energy is released by the system, so the system feels hot. This is any type of flame. In addition to flames, this can be considered hand warmers that you might use while hunting or going to a football game in the fall. Those little packets that when you open them up to the air and you shake them up, the iron mixes with the air and creates a chemical reaction. That's considered an exothermic reaction, which feels hot. Now that's the easy thing to think of. So we're going to take a look at two of these examples in terms of pictures. Each beaker is considered the system, that is a closed system where the reaction is taking place. And outside the beakers is considered the surroundings. So we have two systems and all of the surrounding areas. And the system has a total amount of potential energy. In an endothermic reaction, that system is absorbing energy from its surroundings. So this energy is going into the beaker, so when we touch the beaker, it feels cold. In an exothermic reaction, the system is giving energy to the surroundings, so it's actually releasing energy. This is why it feels hot. So endothermic feels cold, absorbs energy. Exothermic feels hot, releases energy. Now this heat energy that's being transferred, we call it a value of a delta H, which stands for heat energy. And the issue with the delta H values for these two systems is that they're opposite of what we think. In the endothermic, since it is absorbing energy, our delta H, or our change in heat, is actually going up. It is a positive value. It's absorbing it from its surroundings, so it has a positive number. Since we are releasing energy in the exothermic reaction, our delta H is going down. Our energy is leaving, so it's considered a negative number. So in this unit, we're going to be looking at heat in terms of chemical reactions, and those H values are telling us, are we absorbing or are we releasing? Do we feel hot or do we feel cold? So on this next slide, we have two types of graphs, and these two graphs show exothermic and endothermic reactions and the delta H's. So here, this is the energy that we are starting with. This is the potential energy that is in that reaction. Once the reaction takes place, this is the energy that we're ending with. Since we are releasing heat and it feels warm, this is a negative sloped line to go from our reactants to our products. So heat is released, delta H is negative, it feels warm. This is the exact opposite for endothermic reactions. This is our reactant line. This is our product line. We absorb heat. Delta H is positive, and it feels cold. So when we go from here to here, let's pretend that little blip isn't there. This is a positive slope because our heat of that substance is actually increasing because it's taking it from everything around it. When you touch a cold pack, it's trying to steal the heat from your hand to warm its molecules up. That's why it feels cold to you, because it's taking the energy from your fingertips to attempt to give it to the molecules in the cold pack. So again, this can be kind of confusing. We're just going to be working on determining if it's endothermic and exothermic at first, and then we're going to go a little bit deeper into these relationships. So I'll see you so we can work on this.